Hello and welcome to what will hopefully become a series of video tutorials of me creating some new OHLE for use in Train Simulator using Blender. I'll be using the new Train Simulator method of OHLE, and I warn you, I'm not a Blender expert and these videos are likely to be fairly rambling, but I will do my best. I'll be uploading my source files at the end, and hopefully with a bit of luck at the end of the series we'll end up with a load of resources free to everybody, some OHLE using the new system. So we've got a brand new Blender window here. Let's delete that box, right click X and delete. And I've also done a fair amount of research before starting this, finding out information about how OHLE in the UK, of measurements and dimensions and all sorts of things like that. So the first thing I want to do is to add the nodes for the contact wire and the continuous support wire. The contact wire is the wire that the pantograph will touch. Now the nodes are used because the wires themselves using the new system in the game are actually lofts, and so if you make nodes you can connect the lofts together, and that's what allows you to do the zigzag as you go down the track and the correct spacing and all the rest of it. So let's add our first node. Now from my research I know that from the rail head the height in Railworks is 5.5 meters to the contact wire. Now that's actually quite high. Unfortunately at the moment pantographs don't follow the height of the contact wire. The normal height is 4.7 meters. But as I say, it can range, this is all the information here, it can range up to 5.6 maximum and down to 4.1 minimum. Railworks or Train Simulator uses the default of 5.5 for the UK, so we've got no choice. That's what we're going to have to use for the height of the contact wire. Otherwise our pantographs will be either above or below that wire, which will look a bit daft. So let's add that first node in. So we're going to make a simple plane, and I'm going to go to Control and 1 view, Control and 1, which is back view, and we're going to add that first plane in. I'm going to align it to view, and I only want a very small plane, so each unit in Blender I treat as a meter, so I only want a 10 centimeter by 10 centimeter plane, so that's a 5 centimeter radius. So 0.05 is 5 centimeters. Okay, I'll use the dot on the numpad to focus on that object. I'm going to give that a plane a name in the Train Simulator format, 1_250, so that's our distance, 250 _ contact node. Okay, we need that node to be 5.5 meters above the railhead, and the railhead will be at the origin at 0, 0, so 5.5. Should jump that up. Okay, so the center of this node is at 5.5 meters, not the bottom but the center of the node. So that's just something to bear in mind. I'm not sure, I'm going to have to tweak that up a little bit by say 5 centimeters, make the bottom of the node aligned to that point. Now the next thing is that the contact wire zigzags left to right as you go down a straight. Now on a straight, that stagger, that zigzag, is usually a maximum of 9 inches or 22.86 centimeters for Mark 1 or 230 millimeters, 23 centimeters for Mark 2. On curves it can increase. So I'm going to go for Mark 3. I'm going to base our measurements where possible on the Mark 3 because that's what I'm going to be modelling mostly for my route. That's a Transpano route. So I will need to move this to the left by 23 centimeters. So again, to do that, the left axis is X, so 23 centimeters is 0.23. Okay, so that's our contact wire node done. Now I'm going to duplicate that plane, and then I'll just escape to keep it in the same location. We're going to name that correctly. It's not the contact node, this is going to be cat machinery support node. Now I'm not sure if there's a limit in the number of characters that can be used in object names, so if there is, we might have to shorten that at some point. Again, flicking back to my research information, so we need to know how much higher the support wire is to compare to the contact wire. As part of my research, I've found various images, so this is a very good one. So we can see here, here's our contact wire height, and here's our continuity support wire, and they would normally have a encumbrance, apparently that's what it's called, but a separation of 900 millimeters. So that's what we're going to use. So I need to move this up by 900 meters, so I'm going to grab it on the Z axis, and we're going to put in 0.9 for 900 millimeters or 90 centimeters. Okay, so there's our contact and support nodes. Now this is where I'm going to try something new. I've not done this before. As you can see, I've got lots of measurements, so I want to try and add some markers into my Blender model for all the various locations, so that I can make all these tubes, etc., easily by adding elements to them. So I can see here that this tube here, I can't remember its name, it might come back to me, is 275 millimeters above the contact wire. So I want to add a marker straight up from here that's 275 millimeters above, and I'm going to hopefully add in all those various extra measurements that I'm going to work out, so that I've got some points to base my tubes from. So let's start off with that first one. So I'm going to go 275 up from my contact wire marker. So we select our contact node. I'm going to add in again a new plane. I'm going to align that to view again. Okay, oh there it is. Actually, no, we're going to undo that. Don't like that. I'm going to put my, first of all, I'm going to select my contact node. Then I'm going to use, I think it's Shift and S to move my cursor to the selected item, so that now when I add in my new plane, it's bang on top of where my cursor is. Align that to the view. Remember, we wanted 275 millimeters up, so I'm now going to grab that with G, Z to lock the Z axis, and go 0.275 on the numpad to move that by 275 millimeters higher. Dot on the numpad. So that is the center point of the tube directly above. Now I'm going to collapse that because I want just a single node. So to collapse, you do Alt and M. I thought it was Alt and M. Let me just find out what the key press is. Sorry, my mistake, it is Alt and M, but I've got to be in edit mode. So tab to go into edit mode, Alt and M, and then collapse to the center. So that's now made a single node at that location. So I'm going to make this new object, I'm going to name this as marker vertices. Okay. So back to our drawing. You can see I've got a measurement here of 500. That's the spacing between this securing point and this point. And I've got the variation here, but it can be between 200 and 125. So I'll take the middle value of 175. So I can add those two together, 175 and 500. So give me 675. And looking at that, to me, that looks about the same distance as this here. So I'm going to take that as 500, 500, and then 175. Because I haven't got the exact measurement of what that be. It's probably a variable measurement, so that's just what I'm going to do. So I'm going to extend my marker by 1.175 meters to the right. So I'm going to go E for extrude to keep the original vertices. I want it on the x-axis, and I want it by 1.175. Well, you see that's gone to the left. I wanted it to the right, so I've just put a minus sign in front of it, and it's gone to the right there. Okay. So I don't know if this is a good idea or not, but this is going to be my method of creating a series of markers to allow me to snap things to and align things later on. Now I'm not going to show you the next series of, because I'm basically just going to be working out all these measurements and placing markers. So I'm going to pause the video and hopefully add in all the markers I need to find all these locations that I want. Right, so there we have it. The marker points are all set out. This is the image that I'm basing it off, hopefully. Scale that down a little bit. Hopefully you can see some similarities there. The theory is that that is the basic structure. So using those markers I can actually create the physical structure that we'll actually export. We won't export these markers. Okay, I think that's probably enough for part 1 of the tutorial, and with part 2 we'll actually start creating the structure. Thanks for watching.